Donner Pass sits at 7,135 feet above sea level in the Sierra Nevada of California. It is not the highest point in the range, but it is the point where the Central Pacific Railroad and later U.S. Highway 40 crossed the mountain barrier between the Sacramento Valley and Nevada. The corridor was cut in the 1860s. By 1948, it was the primary overland route for freight, mail, passengers, and commerce between the Pacific coast and the interior West. Winter was a constant at this elevation. Snow arrived in October or November and lasted through April. Rail operations were built around this. Snowsheds covered miles of track. Rotary plows were stationed at Truckee and Soda Springs. The Southern Pacific Railroad maintained crews specifically for mountain clearing. The highway was plowed by the state. Both systems assumed passage could be maintained. The pass was not wilderness. Small communities existed along the route: Norden, Soda Springs, Kingville. Lodges operated for winter travelers. Service stations, section houses, and maintenance yards lined the highway and the rail grade. The corridor was infrastructure, not empty ground. In late autumn of 1948, the seasonal transition began as expected. Snow fell. Temperatures dropped. Equipment was deployed. There was no alarm. The Sierra had been crossed in winter for 80 years. The first significant storm of the season arrived in mid-November 1948. It dropped 2 feet of snow across Donner Pass over 3 days. Temperatures remained below freezing at summit elevation. Plows cleared the highway. Rotary equipment cleared the rail line. Traffic resumed. A second storm followed within a week. Another 30 inches. Clearing cycles repeated. The snow was heavier than average for November, but not unprecedented. The equipment functioned. The crews worked longer shifts. Passage was maintained. By early December, snow depth at Norden measured 6 feet on level ground. Drifts along exposed sections of highway and rail exceeded 10 feet. Wind patterns concentrated snow in cuts and along embankments. Clearing these sections required multiple passes. Plows pushed snow to the sides, narrowing the corridors. The walls grew taller. Rail schedules began to show delays. Freight trains that normally crossed the pass in 4 hours took 6, then 8. Passenger trains were held at Truckee or Reno waiting for clearance. Highway travelers faced intermittent closures, but alternative routes existed through lower elevations. Inconvenience was noted. Emergency was not declared. The snow did not stop. A third storm arrived mid-December, then a fourth, each deposited between 1 and 3 feet. There was no significant break between systems. The clearing crews worked continuously, but they were no longer clearing to bare ground. They were cutting channels through an accumulating base. December 1948 was colder than average across the Sierra Nevada. Daily high temperatures at Donner Pass remained below 25 degrees Fahrenheit. Overnight lows frequently reached 0 or below. This was not record-breaking cold, but it was sustained cold. There were no thaw cycles. In a typical winter, storms are followed by brief warming periods. Daytime temperatures rise above freezing. Snow surfaces soften. Meltwater trickles into drainage. The snowpack settles and consolidates. Roads and rail lines partially clear themselves between storms. This did not occur in December 1948. The snow that fell in mid-November remained on the ground. The snow that fell in late November buried it. The snow that fell in early December added another layer. By mid-December, the base depth exceeded 8 feet. The surface was wind-scoured and hardened by continuous cold. New snow bonded to the old. The mass became dense and stable. Cold also affected equipment. Diesel engines required longer warm-up times. Hydraulic systems thickened. Rail switches froze despite heating elements. Clearing operations slowed not because of snow volume alone, but because of the mechanical resistance imposed by temperature. Cold affected personnel. Crews worked in shifts measured in hours, not full days. Frostbite became routine. Visibility during storms dropped to near 0. The work was not faster or more efficient. It was simply continuous. By the end of December, snow depth at Norden was recorded at 12 feet on level ground. Drifts in protected areas reached 20 feet. The cold had not broken. No warming was forecasted. In the first weeks of January 1949, the pattern continued. Storms arrived every 3 to 5 days, each deposited between 1 and 4 feet of snow. Temperatures remained below freezing at all hours. The snowpack grew vertically without compression losses from melting. Clearing strategies that worked in November failed in January. Rotary plows could cut through fresh snow, but the compacted base resisted the blades. Passes that had been cleared in the morning refilled by evening. The Southern Pacific began running multiple rotary units in tandem, cutting the same section repeatedly to maintain a single open track. The State Highway Department adopted the same approach on Highway 40. Both efforts consumed fuel, machinery, and labor at rates that could not be sustained indefinitely. By mid-January, the snow depth at Norden reached 15 feet. Measurements were taken at established markers, but markers were disappearing under the surface. New reference points were established using fixed structures, telephone poles, building roofs, shed eaves. The landscape was no longer recognizable by ground features. Navigation was done by memory and by the position of objects that projected above the snow. The snow was no longer an obstacle. It was the environment. The road and the rail line existed as narrow cuts through a continuous white surface. The walls on either side were vertical or overhanging. If a vehicle or train stopped, it could not easily be reached from above. If it became stuck, extraction required equipment that could approach from the same narrow channel. Clearing no longer meant removal. It meant maintaining a slot through static mass. The snow was not going anywhere. Wind across Donner Pass follows predictable patterns. Storm winds arrive from the southwest, driven by Pacific moisture systems. Post-storm winds reverse and flow down the eastern slope toward Nevada, accelerated by the terrain. These winds move snow from exposed areas into sheltered ones. The result is drift formation in cuts, tunnels, and behind obstructions. In January 1949, wind became the primary agent of refilling. A section of track or highway could be cleared in the morning. By afternoon, wind-driven snow from surrounding slopes had refilled it to a depth of 3 or 4 feet. The new snow was not fresh powder. It was compacted granular material, dense and heavy. It did not blow away easily. It settled in place. Certain locations became persistent problem zones. Devil's Gate, a narrow cut on the rail line west of Norden, refilled within hours of every clearing. The Frog Lake section of Highway 40 drifted to depths exceeding 20 feet. Crews returned to these points daily, sometimes twice daily. Progress was measured not in distance but in hours of maintained opening. Wind also shaped the snow surface into formations that resisted equipment. Sastrugi, hardened ridges carved by wind, formed across open areas. These ridges were dense enough to damage plow blades. Cornices formed along the edges of cuts, overhanging the cleared channels. When they collapsed, they buried equipment or track without warning. The geometry of the pass had turned hostile. The natural shape of the terrain concentrated snow where passage was required. Wind ensured that clearings were temporary. Every open section closed again. The Southern Pacific Railroad operated the primary transcontinental line through Donner Pass. In a normal winter, freight and passenger trains crossed the summit multiple times per day. By late January 1949, the schedule had collapsed. Track was cleared in sections, but not all sections were open simultaneously. A train cleared for departure from Truckee might reach Norden only to find the line blocked by fresh snow or a collapsed drift. It would stop. A rotary plow would be dispatched from the nearest siding. Hours passed. The train waited. If another storm began during the delay, the situation worsened. Rail yards became parking zones for stalled equipment. Sidings at Truckee, Norden, and Summit filled with locomotives and freight cars waiting for clearance to continue. Passenger trains were rerouted through Oregon when possible, adding hundreds of miles to the journey. Mail was delayed by weeks. Perishable freight spoiled in refrigerated cars that could not be moved. Switches and signals buried under snow stopped functioning. Track crews dug them out by hand, only to have them bury again within hours. Communication lines went down. Linemen on skis carried messages between stations. The rail network, which had been engineered for reliability, was reduced to isolated segments operating independently. Locomotives idled continuously to prevent freezing. Coal and fuel oil consumption increased. Supplies had to be brought in by the same compromised routes they were meant to clear. Rotary plows required coal, water, and crews. All three were in limited supply at altitude. Equipment began to fail from overuse. By early February, the Southern Pacific was operating at less than 30% of normal capacity over Donner Pass. Highway 40 was the main automobile route over the Sierra Nevada. It paralleled the rail line, often within sight of the tracks. The state maintained it as a year-round road. In winter 1948-49, it ceased to be one. The California Division of Highways deployed rotary plows, V-plows, and grader equipment. Crews worked around the clock. The goal was to keep at least one lane open in each direction. By mid-January, this was no longer achievable. Sections of highway remained closed for days at a time. When they reopened, the corridor was a single lane cut between walls 15 to 20 feet high. Passing was impossible. If a vehicle stalled or slid off the narrow track, it blocked the entire route. Tow trucks could not turn around. Vehicles had to be pushed or dragged backward, sometimes for miles, to a point where clearance existed. Motorists who attempted the crossing were frequently stranded. Some abandoned vehicles and walked to the nearest town. Others waited in their cars until plows arrived. Rescue operations diverted resources from clearing. The highway department began recommending against travel over the pass. Then it stopped recommending and started prohibiting. The road remained officially open, but in practical terms it was unusable. Commercial trucking rerouted through lower passes or ceased mountain crossings entirely. Passenger traffic dropped to near zero. The highway, like the rail line, existed as a theoretical route that could not be reliably traveled. Wind refilled the road as quickly as it refilled the tracks. Drifts formed overnight. Cornices collapsed into the roadway without warning. The state lacked enough equipment to clear faster than snow returned. Norden, Soda Springs, and Kingville were small communities at high elevation along Donner Pass. Their populations were seasonal and small, fewer than 200 permanent residents combined. In winter, they relied on the highway and the railroad for supplies, mail, and emergency access. In winter 1948-49, both systems failed. Deliveries stopped. Grocery stores ran low on stock. Fuel deliveries for heating were delayed or canceled. Mail arrived intermittently, sometimes weeks late. Telephone lines remained functional, but they could not transport goods. The communities were not cut off from communication. They were cut off from supply. Some residents left before conditions worsened. Others stayed, either by necessity or by choice. Those who remained rationed food and fuel. Snowshoes and skis became the only reliable means of travel. A trip to Truckee, normally 30 minutes by car, became a day-long journey on foot. Medical access was compromised. There were no hospitals at elevation. Serious cases required transport to lower altitude. In normal conditions, this was routine. In February 1949, it was uncertain. Requests for emergency access were prioritized, but response times stretched from hours to days. The isolation was not dramatic. There were no mass evacuations, no deaths from starvation or exposure. The strain was logistical and cumulative. Supplies dwindled. Heating fuel burned steadily. Snow continued to fall. The communities endured not by dramatic action but by reduction of activity and consumption. They waited for the road to reopen. It did not. The Southern Pacific Railroad owned multiple rotary snowplows. These were large machines, steam or diesel-powered, with rotating blades mounted on the front of a reinforced locomotive. They could throw snow hundreds of feet to the side of the track. In normal winters, they were sufficient. By February 1949, they were saturated. A rotary plow could clear a mile of track in 2 hours under normal conditions. On Donner Pass, the same mile required 6 hours or more. The snow was dense. The drifts were deep. The equipment worked at maximum capacity. Blades dulled. Engines overheated. Mechanical failures became routine. Crews operated in continuous rotation, but machines could not. Downtime for repairs increased. Parts were ordered but could not be delivered quickly because the route they were needed to clear was the same route required for their transport. The system began to fail from internal dependency. The State Highway Department faced identical problems. Rotary plows worked until they broke. Replacement parts were improvised or cannibalized from other equipment. Fuel consumption exceeded supply. Crews worked until exhausted, then returned to work the next day because no replacements existed. Net progress approached zero. A section cleared in the morning was blocked again by afternoon. A section cleared on Monday was blocked again by Tuesday. The same ground was cleared repeatedly. Labor and fuel were consumed without forward gain. The machinery had not failed. It was simply insufficient for the scale of the task. The Southern Pacific Railroad owned multiple rotary snowplows. These were large machines, steam or diesel-powered, with rotating blades mounted on the front of a reinforced locomotive. They could throw snow hundreds of feet to the side of the track. In normal winters, they were sufficient. By February 1949, they were saturated. A rotary plow could clear a mile of track in 2 hours under normal conditions. On Donner Pass, the same mile required 6 hours or more. The snow was dense. The drifts were deep. The equipment worked at maximum capacity. Blades dulled. Engines overheated. Mechanical failures became routine. Crews operated in continuous rotation, but machines could not. Downtime for repairs increased. Parts were ordered but could not be delivered quickly because the route they were needed to clear was the same route required for their transport. The system began to fail from internal dependency. The State Highway Department faced identical problems. Rotary plows worked until they broke. Replacement parts were improvised or cannibalized from other equipment. Fuel consumption exceeded supply. Crews worked until exhausted, then returned to work the next day because no replacements existed. Net progress approached zero. A section cleared in the morning was blocked again by afternoon. A section cleared on Monday was blocked again by Tuesday. The same ground was cleared repeatedly. Labor and fuel were consumed without forward gain. The machinery had not failed. It was simply insufficient for the scale of the task. Buildings along Donner Pass were constructed for winter. Roofs were pitched steeply to shed snow. Walls were braced. Foundations were deep. In winter 1948-49, the design assumptions were tested. Snow accumulated on roofs faster than it could slide off. The steep pitch that normally cleared itself became irrelevant when snowfall exceeded shedding capacity. By February, roofs throughout the region carried loads of 6 to 8 feet of compacted snow. The weight was immense. Structures groaned. Beams flexed. Some buildings collapsed. Railroad snow sheds, long-covered structures that protected the tracks, were designed to carry heavy snow loads. Several failed. Roofs buckled inward, splintering beams and blocking the track below. Clearing the debris required days of labor. Once cleared, the shed was no longer functional. The track it had protected was now exposed. Warehouses, depots, and service buildings sustained damage. Walls cracked under lateral pressure from drifted snow. Doors could not be opened because snow pressed against them from outside. Windows broke. Structures that did not collapse were often rendered unusable. The snow was not wind, it was weight. It pressed downward continuously. It did not yield, it did not melt. Every day added more. Support columns in rail yards were reinforced with timber bracing. Roofs were shoveled by hand when equipment could not reach them. The work was slow and dangerous. Men climbed onto roofs carrying shovels, working in wind and cold to remove tons of snow, one load at a time. The snow was no longer weather, it was static load. The rail line and highway over Donner Pass were not the only routes through the Sierra Nevada, but they were the only routes at that latitude that remained open year-round under normal conditions. Other passes were higher, narrower, and closed in winter. Rerouting was possible but costly. The Southern Pacific rerouted some freight through Oregon. This added 300 miles to the journey. Schedules were delayed by days. Capacity was reduced. Trains that would have crossed the Sierra in hours now traveled for a day or more. Costs increased. Revenue decreased. The pass was not open, but neither were the alternatives simple. Trucking companies faced similar constraints. The main alternate route through the Sierra was Highway 50 over Echo Summit, 50 miles south. It was lower in elevation and less prone to extreme snow, but it was not immune. In winter 1949, Echo Summit also experienced heavy snow and closures. Trucks that rerouted south found themselves waiting there as well. Air transport was not an option for freight. Commercial aviation in 1949 was limited to passengers and mail. Heavy cargo moved by rail or by road. When both were blocked, it did not move. Delay compounded. A shipment delayed by 1 day missed its connection. A connection delayed by 2 days disrupted schedules downstream. The blockage at Donner Pass rippled through the logistics network of the western United States. There was no alternative with equivalent capacity. The pass had to reopen. It did not. On several occasions in February and early March 1949, clearing crews achieved temporary openings. A section of track was cleared. A train passed through. The line was declared open. Then snow returned and the line closed again within hours. These breakthroughs were not victories. They were brief windows. Equipment was mobilized immediately to take advantage of the opening. Trains departed from Truckee or Reno in convoys, attempting to cross before conditions deteriorated. Frequently, they did not make it. A train halfway through the pass when snow resumed was stranded at altitude. Rotary plows had to be dispatched to extract it. The highway experienced the same pattern. A lane was cleared, travelers were notified. A few vehicles attempted the crossing. Some succeeded. Others became stuck and blocked the road for those behind them. The opening closed. The cycle repeated. Optimism was brief. Each opening suggested the worst was over. Each closure confirmed it was not. Crews stopped celebrating clearings. They knew the snow would return. Weather forecasts offered little guidance. Storm systems arrived without long warning. Clear days were rare and short. The pattern was unbreakable: snow, wind, cold, accumulation. By late February, no one expected sustained passage. The goal was reduced to maintaining access for emergency use. Even that was not consistently achieved. Winter 1948-49 was not defined by a single catastrophic storm. It was defined by duration. Snow fell for 4 consecutive months without significant interruption. Cold persisted without thaw cycles. The pass remained inaccessible not because of a single extreme event, but because the extreme condition did not end. Equipment wore out. Machinery that had been new in November was failing by February. Rotary plows needed overhauls. V-plows needed blades. Diesel engines needed rebuilds. Maintenance required facilities, parts, and time. All were in short supply. Personnel fatigued. Crews worked through Christmas, through New Year, through February. Shifts blurred together. Men worked until they could not, rested briefly, and returned. Injuries increased: frostbite, exhaustion, accidents. The work did not stop, but efficiency declined. Infrastructure degraded. Rail ties buried under snow shifted without the weight of passing trains to hold them in place. Embankments weakened. Bridges carried loads of snow they were not designed for. Damage was hidden under the surface, waiting to be discovered when the snow finally melted. Time became the enemy not because it passed quickly, but because it passed slowly. Days were long, weeks were longer. The end of winter was expected in March. March arrived and snow continued. The pass had been closed for extended periods before, but not like this. Previous closures lasted days, occasionally a week. This one lasted months. In mid-March 1949, daytime temperatures at Donner Pass began to rise above freezing. The change was slow. Nights remained cold. Snow still fell, but less frequently. The storms weakened. The intervals between them lengthened. Melting began at the surface. Icicles formed along the edges of cuts. Water trickled into drains that had been frozen solid for months. The snow did not disappear, but it softened. The hard, compacted surface that had resisted plows began to lose density. Clearing became easier. Rotary plows cut through snow that a week earlier would have stalled them. Highway crews advanced farther each day. Drifts that had refilled overnight now stayed clear. Progress was measurable. By early April, sustained passage was achieved. A train crossed from Truckee to Reno without stopping. The highway opened to controlled traffic. Vehicles moved in single file through narrow corridors, but they moved. The pass was not fully clear, but it was functional. Snow remained on the ground in massive quantities. Walls of snow 20 feet high lined the road and tracks. They would remain for weeks, slowly shrinking under spring sun. But the active accumulation had stopped. The blockade ended not with a dramatic breakthrough, but with gradual moderation. Weather changed. Equipment caught up. The pass reopened because conditions allowed it, not because conditions were overcome. By late April, full operations resumed. The winter was over. Snow depth at Norden during winter 1948-49 was recorded at multiple points. The maximum depth on level ground reached 18 feet in late February. Drifts in protected areas exceeded 30 feet. Total seasonal snowfall was estimated at over 50 feet, measured cumulatively. The Southern Pacific Railroad reported delays totaling thousands of hours. Freight schedules were disrupted from December through March. Revenue losses were significant but not published in detail. Equipment damage included multiple collapsed snow sheds, damaged locomotives, and worn-out rotary plows. California's Division of Highways documented similar impacts. Highway 40 was closed or restricted for most of January, all of February, and half of March. Estimated vehicle crossings during the winter were less than 20% of normal. Equipment losses included destroyed plows and vehicles buried and abandoned. No fatalities were directly attributed to the blockade. Injuries were recorded but not systematically compiled. The human cost was measured in labor, not lives. Mountain communities reported supply shortages but no critical failures. Food, fuel, and medical access were strained but maintained. Residents described the winter as severe, prolonged, and isolating. Some left permanently after spring arrived. The economic impact extended beyond the pass. Delayed freight affected commerce throughout the West. Perishable goods spoiled. Time-sensitive shipments missed deadlines. Industries reliant on transcontinental rail adjusted schedules and supply chains. The winter was not a disaster. It was a sustained failure of passage. After winter 1949, the Southern Pacific Railroad reevaluated its approach to Donner Pass. Snow was no longer treated as a predictable seasonal obstacle. It was reclassified as a persistent risk requiring permanent mitigation. Additional snow sheds were constructed over sections that had repeatedly failed. Rotary plow fleets were expanded. Fuel and parts stockpiles were increased at high-elevation yards. Communication systems were upgraded. The goal was not to prevent snow, but to reduce dependency on continuous clearing. The state of California reached similar conclusions. Highway maintenance budgets for the Sierra Nevada were increased. Equipment was prepositioned at higher elevations before winter began. Plans were developed for extended closures, including supply caches and emergency shelters. The winter of 1948 to 49 was studied, documented, and referenced in engineering reports for decades. It became a benchmark, not the worst imaginable winter, but a real one, survivable but not without consequence. Donner Pass remained the primary corridor through the Sierra Nevada. It was not replaced, it was reinforced. The snow had not been defeated, it had been acknowledged. By May 1949, the pass was fully open, traffic resumed, snow melted, the corridor returned to normal, but the memory of the winter remained fixed, a season when the mountains closed and passage was not assumed but earned.